All right, we are continuing in lesson 7 on markups and markdowns, and we'll continue our work with percents. So Sasha went shopping, excuse me, and decided to purchase a set of bracelets for 25% off the regular price. If she buys the bracelets today, she's going to save an additional, we've seen that word before, additional 5%. We want to find the sale price with both discounts. Remember, we do not add the percents together. So, and then we'll come back to see how much money she'll save. So one way to think of this is, again, if she's getting 25% off, 100 minus 25 is 75%. So she's paying 75% of the price. Okay? If she's going to get an additional 5% off, that means she's paying 95% of the price. Okay? So if we have 100 and we take 25 off, we're left with 75%. We have 100 and we take 5% off, she's left with 95%. So if we work backwards here, she's actually paying 95% of 75% of the original price. Well, what is the original price? It's right here, $44. Okay. So again, if we change these to decimals, we move it 2 places to the left and drop the percent sign. Of, remember that's out of, that's where we're multiplying by. And then I move this to a decimal, and that's 0.75 of 44. And then if you type that into a calculator, nope, we get 0.95 times 0.75 times 44 is 3135. So what we're saying is if she is paying 95% of 75% of the total cost, she's going to be paying $31.35. Now, that is not the only way to do this problem. Okay, so if you're like, oh, that doesn't make sense, don't stress. Remember, we could go back to our quantity equals percent times whole. So our quantity, I'm going to call X, equals our percent, 0.25, times our whole, $44. Now, if you multiply these together, you get 11. Okay, so that doesn't mean that she's paying $11. It means that if you take the original price minus 11, you're going to get $33. So after our first discount right here, 25% off, she's going to be paying $33. But then she gets an additional discount, right? So now our whole price is 33. I'm going to do quantity equals our new percent, 0.05 times our new price, $33. If you type that into a calculator, that equals 1.65. So $1.65, which means that her new price of $33 minus $1.65, and guess what that gives us? $31.35. So I want you guys to see that either way you choose to do this, you're going to get to the same answer. So this part, you're like, yep, I got it. This is quicker and shorter. But if you're like, that doesn't make any sense to me, then do it this way until you get more comfortable. The last thing we have to do is we have to figure out how much money she's going to save. Okay, so we'll come over here for that. The bracelets were $44. She is paying $31.35. So if you subtract those two things, you get $12.65. So she saved $12.65. Okay. Let's look at another example involving percents. So a golf store purchased a set of clubs at a wholesale price. Okay, so that was like the first example we did. Think back to wholesale. Okay, the store purchased it for $250. So they need to get that money back so they break even. He learned that they were marked up, Mr. Edmund here, 200%. Is it possible to have an increase greater than 100%? The answer to that is yes. Okay, because remember, 100% of 250 is 250. The store needs to make 100% of what they paid back. Okay. All right, so if it's a 200% increase, they're going to mark it up that 100% a couple times. Okay, so let's talk about that again. Let me maybe write it down so it makes more sense. For them to make their money back, 100%. They've got to get $250. Okay. Now, if they're marking it up, and I'm going to try to spell it right. Their markup is 250%. Nope. Their markup is 200%. Sorry. So, originally, to get what they have back, 100%, plus they have their markup of 200%, which means that's a total of 300%. 300% of the wholesale price. So 100% of the original plus the markup of 200%. Now, is it possible? Yes. Okay. What is the retail price? The retail price is what they're going to sell it for. So just like we've been doing, make it into a decimal, 3, times our wholesale price, 250. Remember, that's our original. And that means the golf clubs are going to cost $750. Okay. This is what stores do. They purchase it. They have to get 100% of their money back. But they also need money to make a profit, to pay employees, to pay bills. So that's why they mark it up. Totally okay to mark it up 200%. Notice that we're taking that 250 and basically multiplying it by 3. All right, let's look at a couple more examples here. Working backward. All right, so what if we know now what it sells for and we want to figure out what it was originally? Okay, we're going to go back to this formula we've been using. Quantity equals percent times whole. Okay, what percent? So we know right away we're looking for the P. What percent of the original price of the car is the final price? Okay, so our final price is going to be the quantity. So notice up here it says a car that normally sells for $2,000 is on sale for $16,000. Okay, so this is the final price. That's $16,000 right here. And the wholesale is $20,000. Okay, that's what it was originally, normally. Right? What are we solving for? P. What do we got to get rid of? 20,000. I'm going to undo my multiplication with division. Whatever I do to one side, I do to the other. Make sure I have enough zeros here. Take this, and if you divide it into a calculator, you get 0.8. That's not a percent, though. We got to move it over 2 times, and we are going to be paying 80%. Okay? So again, it should make sense. What percent of the original? Well, we're paying 80% of what it originally costs. Now, we want to do the discounted rate. Okay? Well, the discount rate is how much it was discounted. Well, if we paid full price, that'd be 100%. But we're only paying 80% of the cost, which means the discount rate is 20%. Okay? And I know it talks about sales tax up here at 7.5%. We're not going to worry about that in this problem. All right, last example here. It says write an equation and determine the selling price in dollars, P, on an item that is originally priced S dollars after a markup of 25%. Well, if it's a markup of 25%, remember we're paying 100% of the original price plus a 25% markup. So we're actually going to be paying 125%. Now, we're going to be paying 125% of the original price. That's our whole, right? So I make this into a decimal. So it's 1.25 times our original price, which we call S. And that's going to be our selling price. There's my equation. Our selling price is 1.25 times our original price. Now we need to create a table showing 5 possible values. Well, the truth is, guys, we don't know what those values are, so we get to pick them. So I am going to put S over here. Okay, remember that's our original price. Sorry that I'm struggling to spell. That's price right there. Then over here, we're going to have P, and that's going to be our selling price. We're going to see how this ties into things we've been doing. Okay, so pick a value. If I sell it for, if the original price is $0, what's 1.25 times 0? 0. If I sell it, I'm sorry, if the original price is $10, I go 1.25 times 10, and that's $12.50, right? 12.5, but it's money. You can pick whatever you want. Just to make things easy for graphing, because you see a graph down here, I'm going to do 20. $1.25 times 20. That becomes $25. And these numbers, I'm just picking these and multiplying them. 30. That would be $37.50. And 40. That'll give me 5 here, right? 6, nope, 50. All right, so now we're going to take these things and we're going to put them on a graph. So maybe I can make this a little bit smaller here. All right. So I'm just going to use the edges. Okay, and remember, our X value in this case is going to be our original price. So I'm just, for the sake of time, say that's S. And our selling price will be our y-axis here, P. So let's plot these points. 0, 0 goes right here. And I guess I should look at my scale. S values is going from 0 to 40, so I'll just tell you I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8, 30, and then that should put us here at 40. Okay, and going up this way, I think I'll go by 5s. 5, 10, 15, 20, 30, 40, 50, and we'll stop at 60. Okay. Already got 0, 0 on there. Then I'm going to put 10 and 12.50. Remember, this is an ordered pair. So 10 and 12.50. This is 10, this is 15, so 12.50 would be halfway in between. Then I have 20 and 25. So here's 20 and 25 would be right here. 30 and 37.50. That's 35, halfway between would be here. And 40 and 50. All right, so when you look at this, what do we notice? Straight line going through 0, 0. Notice that this is a proportional relationship. Kind of tie in what we did earlier in the year. And what we could do was we could look at here, if I said, hey, something is, $32, we could see that it would, the original price was 32, the selling price would be 40. All right, so keep in mind, be careful looking with our percents, knowing that markups mean we're going to add it to 100%, but markdowns we're going to subtract it.